Well, hello good people, we are back once again with our Comfyui 101 series, and in today's video we're going to create an inpainting workflow. Now what you see on the screen is the workflow we're going to work towards today, and I want to show you this quick example of a before and after of this image that I created and used Inpainting to fix the little details. But generally speaking, to me, Inpainting is like touching up your image, fixing little details before you move on to upscaling. So first and foremost, we need the Inpainting model. As always, I'm going to leave a link to this Google Doc where you can get all the Flux models that we've worked on in this series. And towards the bottom here, you're going to see an area for Flux Inpainting and Outpainting. The first one is the original model from Black Forest Labs. And if you have a GPU that can handle it, it's a whopping 23.8 gigabytes. You can go ahead and download it by clicking on this arrow. Now for most of you, you may want to run the FP8, the GUF variations. So if we click on the FP8 version, this is going to bring you to Civet AI. You see here it's just over 11 gigabytes. And the GUF versions, they range from 5 to 12 gigabytes. So based on your GPU specs, you might want to use one of these. Next, we're going to need a custom node. So let's go up to our manager. And within custom nodes manager, I want you to search for Inpaint Crop. And this is the custom node we want, Comfyui Inpaint Crop and Stitch. Shout out to the developer iCasada, the developer of this custom node. This has made inpainting so much easier compared to all the other workflows that I have seen. The other custom node you should already have if you've been following this series, and that's RG3's Comfyui nodes. Go ahead and install that. And as always, make sure that you're on the latest version of Comfyui, so go ahead and update all, restart Comfyui, and let's get started. Now, I truly believe in working smarter, not harder. So what we're going to do is take our previous image-to-image workflow and use that as a starting basis. If this happens to be your first video you're watching on my channel, this is a series of videos. So make sure that you watch those other videos before this one. And what we're going to do with this workflow is first we're going to remove the image resize node, the power LoRa loader, get rid of that. And VAE encode, we don't need that. And the rest of the workflow is just sort of our standard image generation workflow. So go ahead and double click and type in diff. And the one we want here is differential diffusion. Click on that. And I'm going to explain what these nodes are after we create the workflow. So go ahead and just put this around here, and we'll come back to that in a second. And then the next node we want, we can go ahead and right click, add node. Under conditioning, you'll see a section for Inpaint right here. And then the top one, Inpaint model conditioning. Let's click on that. And let's put this over here for now. I'm actually going to delete the background for now. We don't need it. Next, we want to load all the inpainting nodes that we need. So once again, let's go ahead and right click, add node. Under Inpaint, you'll see 4 nodes here. Go ahead and add all these 4 nodes. And just for the sake of keeping things color coordinated, I'm going to select all these new nodes and put a purple color so that we can see which nodes are for inpainting. So let's put these out of the way for now. I'm going to put Inpaint Stitch over here. So obviously we need to load the inpainting model. So let's get rid of this one. Now it's up to you if you want to use the GUF version or the FP8 version. Either or. We want to double click and type in unit. So we're either going to use load diffusion model or unit loader GUF. I'll do both just to show you. And then we also need our dual clip loader. So type in dual. And for the GUF variation, there you go. So if you're using the FP8 version, you should see the FP8 Flux fill model here. Weight type you could leave on default. If you want to speed it up a little bit, you can use the fast version. That'll speed it up just a little bit. Totally up to you. And then we can load our clip L and the T5 text encoder, which is FP8. Well, I'm using FP8. And as always, the type we want to change to Flux. If you decide to use the GUF version, you should be able to see Flux fill here. Here's the Q8 version that I have on my system. And then we want to load our text encoder just the same way. Next, we want to load model to model into the differential diffusion node. So model to model. And then we're going to connect this model input to the sampler right here in the K sampler. So we'll go ahead and do that. And as always, the clip encoders, we want to connect clip to clip in both positive and negative. And you would do that with the GUF versions as well, okay? So I'm just going to delete this because I'm using the load diffusion one, and I'm going to give it a color of blue, and we may as well change the shape to box, this one too. Next, we want to take care of this Inpaint model conditioning. So the hint here is the name conditioning. It's a conditioning node. And if we look at the inputs, we have positive, negative, VAE, so on and so forth. If we look at our nodes, we see we have conditioning nodes on Flux guidance going into the K sampler. So that gives you a clue that we need to put it in between here. Let's make some space. It's going to pull these over here, and then we'll bring this node down, and then we're going to connect conditioning to positive, the negative conditioning to negative. We also want to connect the VAE, and I just realized that we don't have a load VAE node, so let's go ahead and install that. Double click, type in load, and then you'll see load VAE. Give it a shape and color, and now we can connect VAE to Inpaint conditioning. There we go. These two will connect later, but for now, let's connect this end to the sampler. So once again, positive to positive, negative to negative, and latent to latent. Let's take this node and bring it over here. That'll be the last one we'll connect. And then we get to the guts of the Inpaint nodes here. So the first one we want to connect to our load image node here is the Resize image before inpainting. So image to image, mask to mask. Next, we want to put in the extend image for outpainting. We'll go over outpainting in a separate video just to save time, but we may as well connect it for now, and then we're going to bypass it. So same connections, image to image, mask to mask. And while we're here, let's right click and bypass, as we're not going to use it today. And then Inpaint Crop node, same thing, image to image, mask to mask. So next, let's grab the Inpaint model conditioning just to put it closer for now. And then we're going to connect the cropped image to pixels, and then the cropped mask to mask. And then this last input here, stitch, we're going to connect that to the Inpaint stitch node. I'm just going to bring it down. Let's connect that. We'll bring this back up, and then move the save image node and connect the image input into Inpainted image here, and then this image input to save image. Now, what I like to do with this workflow is do a before and after comparison. So like in the upscale video, we're going to add another image compare node. So double click and type in image compare, and that should be from the RG3 node. I'm going to give this a different color just to differentiate the two, and this one will do the same, and we'll line it up so that it's the same size. And then on the original save image node, you should already know how to do this, but let's go into our properties, right click, properties, enable has second tab. We're going to click on this box here, and then we'll right click, properties, click on second tab text, and put compare, click on OK. We want to right click, click on properties, enable tabs, click on the checkbox. And then we want to make sure the other one is lined up. And now we can go between the nodes fairly easily. Now, for the sake of my sanity, I'm going to rearrange the nodes and reroute them just so I can explain the settings. All right, that's much better. So let's talk about the nodes and each setting. So once again, make sure you load the Flux fill model, text clip encoders in VAE. And a quick thing about differential diffusion. Actually, let me pull up a cool little article I saw way back then. So when we do a mask, it's often done in black and white. Anything in white is what is going to change in the image, and anything in black is not going to change. That's basically what a mask does. The problem is when you do a mask like this, the output of the image without manipulating any of the settings or adding extra nodes, you're actually going to see the seam of the area that you masked. And when you use differential diffusion, it gives you this nice feathered gradient mask so that it blends things properly. So in the early days of masking in Comfyui, you had to use like 2 or 3 different nodes just to get this one effect. So now with this node, this kind of gives us the ability to do that easily. When you're doing inpainting and outpainting, I recommend starting with a flux guidance of 30. You could even go lower to like 10 or 20, maybe even higher up to 40 and 50, but I find 30 is a good starting point. Not sure why that is, but for inpainting and outpainting, you need a high flux guidance. This node, Resize image before inpainting, it's not really necessary to have because in this node, we also have a similar function here. Basically works the same way, but it's a good node to have for, let's say you have a smaller image, maybe you did it in SD 1.5. You can use this to sort of upscale the image, but don't get me wrong, this isn't an upscale node. We're not upscaling it 2 or 3 times the image. What it does is that when you mask an area at a small size, let's say that size is 300 by 300 pixels. If we set it to 1024 and select ensure minimum size, it's going to generate that masked area in a 1024 resolution. So that way you get the best quality. So the rescale algorithm here, I typically use Bilerp or Lanzos. Those are the best quality, maybe slightly slower, and then nearest will be your fastest one. To be honest, it's not going to make a huge difference, but those are typically what I like to use. As I said, for the mode, when you select ensure minimum size, you could manually put in a size here. I recommend at least 1024 for SDXL and Flux. If you're using SD 1.5, you can go 512 or even 768. Now the other mode is factor. So let's say I just wanted to do 1.5 times upscale. I could just put that in. So that works pretty well too. I'll talk about context mask later because it's better if I demonstrate what it does for you. Once again, we've bypassed outpainting. We'll cover that later. Now for the Inpaint Crop node, generally the default settings are going to work great. But this is the key node in this whole process. And basically what happens with inpainting is that when you mask an area, it's going to crop just the masked area. And during that process, it blurs the pixels and regenerates those pixels into a new image depending on your denoising strength. So all these settings is what controls that. Context expand pixels, leave it on 20. And basically what that is, once again, if we look at this example mask, if we increase the context pixel, the mask is going to grow around that selection by the amount of pixels that you put. You can also increase that factor here once again for, let's say I wanted to increase it by 25%, I can enter that there, but usually 1 is fine. Fill mask holes. If you do a mask and there's little holes that maybe you didn't see them visibly, this ensures that it closes that area. These two settings, blur mask pixels and blend pixels. Again, if we go back to this diagram, which is super useful, around the edges, it'll blend and blur based on the amount of pixels of your mask. And that's important because it takes care of removing the seams from the mask. Invert mask is self-explanatory. You can invert the mask. So let's say I selected a person, but if I put this on true, it's going to flip it. And then we can use it to change the background, for example. Now, the rest of these settings was from the same node that we just looked at here, except the mode has more settings. So if we click on the area here, you see we have range size, force size, and free size. For SDXL and Flux, it's recommended to use force size and 1024 by 1024. Typically, you want to put your native resolution in there. If you select range size, this is mostly used if you're using like SD 1.5. You can put your minimum width and height here, 512 by 512, and your max width and height, 768 by 768. And there's also padding in pixels. And then the last option is free size, where you have a factor, again, like the other one, where we can put a factor of 1.25, for example. But most of the time, you're going to use force size at 1024 by 1024. So that's why I was saying that this isn't really necessary because the node we just looked at takes care of that. I would only recommend using this node if you happen to have an image that's smaller and you want to do a slight upscale. The last node, the Inpaint Stitch node, you'll see it has that rescale algorithm again. I recommend using Bilerp or Lanczos because it has the best quality. And what this node does during the Inpaint process, it generates the image in its native resolution and stitch it back on the original image. And based on the settings that you put in here, will determine how seamless it's going to look. The only thing I would change here most of the time is the blur mask pixels and blend pixels. I've used it as high as 32, but typically 16, 24 should be enough, 32 at the most. Now it's best that I demonstrate that, so I'm going to upload an image here. And the way this works is that we right click onto the load image node. You'll see an option here, open in mask editor, and then we'll get this interface. You can zoom in and out with a scroll wheel, and you can move around by holding spacebar and holding your left click button on your mouse. You have your controls here, paintbrush, eraser, fill, and eyedropper, typically only good for like certain colors, especially bright colors. And then at the top, you have your undo, redo. You can invert the mask there, clear, and save to node. And then on the right, you have various settings. So as I selected the tools on the left, you're going to notice for each option, they have different settings, all pretty similar. But if we look at the brush options here, we have round or square. So if I pick square, you see my cursor is square. And then we have the thickness. So if I put this all the way up, we have a big masking area. You can play with the opacity as well. So you see here, it's not as thick. So the hardness, obviously, how hard that mask is going to look. If I crank the opacity up and you see the edges are pretty stiff, and I can alleviate that with the smoothness precision here and bring that hardness down a little bit. You see it's not as harsh on the edges, right? See that? It's got a little bit of a feather. And then we can change the mask look to like white or negative. Then there's also an opacity slider for the mask. And let's do a quick example so I can explain the rest of the settings. So I'm just going to paint over her face here. And once you make that selection, click on Save. And then on the Load Image node, you're going to see that the mask is now over the face. For sampler settings, 20 is usually fine. You can go up to 30. Since we're using Flux, CFG should be at 1. And Euler Beta works fine. You can even use Days, SGM Uniform. And denoising is important. Basically, the lower the number it is, the more it's going to look like the original. But let's say you want to recreate the face totally different. If you use a high denoise strength with Flux, if you go even as high as 0.8, 0.9, it can handle it. It won't go too far. For now, I'm just going to leave it at 75 to demo this. And let's go ahead and click on Q. Now it looks like I didn't connect the VAE to the VAE decode, so make sure you connect that from the Load VAE node. All right, let's try that again. But I do want to show you how the context mask works and basically how crop and stitch works. if you recall, we masked just the face area. So again, what this node does, it crops just this area to ensure we touch nothing else. However, it's only affecting the masked area that we had selected. The cropped area is known as the context area, okay? And that's important to know because after this runs, I'm going to show you what this optional context mask does. All right, here's the generated image. Let's flip over to the compare area here. And I'm just going to zoom into the face because that's what we inpainted. And you'll see here's the before, here's the after. One thing you'll really notice is how bad the mouth and the teeth area here. And look at the eyes. And we see that we have a much more coherent image. Now, the one thing you'll notice with this Flux fill Inpainting, it does have sort of more of a plastic smoothing effect, which is fine because what we can do is improve it using the upscale method in the previous video. But in terms of correcting the mouth here or little details, this is where Inpainting is really powerful. So now let's talk about this optional context mask. So what we're going to do is hold Alt while we select the load image node. We're just going to duplicate that and let's open in mask editor, just clear the mask here. And we're going to select the corners here down to the shoulder. So we have 2 points here and let's save that. And we're just going to connect the mask to optional context mask right here. And we have to make sure that we connect it to the other nodes. So let's put it there and connect it up here in the Inpaint Crop node. So now if we generate, let me click on Q. Now if you notice the surrounding area that's cropped, we have a wider context area for the model to sample. We can use this method to get more information from the original image here, right? Now what we're going to do in the next video is take an image like this, improve the details with Inpainting, and finalize those details with upscaling. Now as always, let me know what you think in the comments below, and this happens to be your first time watching one of my videos, make sure to check out the rest of the videos in this series. Until the next video, my friends, I'll see you when I see you.